Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone and welcome back to my lectures. Today I am going to talk about problem solving strategy for IR and mass spec combined spectra. session 1 وهتكون اكتر الى الاندر جراديويت ليفل، لان الجراديويت ليفل محتاج ان انا اكمل ال NMR ويبقى الكومبايند سبكترا عباره عن IR وماس سبيك و NMR. Okay. First example. What is the structure of the compound? Has the following IR and mass spec. Here we have an IR sheet. Recall the 5-zone sheet I asked you to work on. Have it with you ready. Okay, and let's look for the spectrum. Here we can say that we have any peak in here. So the first peak we can see is 2977 up to 2876. This area belongs to aliphatic part, sp3 carbon hydrogen stretch. We have here strong peak, very clear, it is 1737. This is belong to CO. We can see peak here at 1194 and 1166 for CO stretch. So from the infrared, it's clearly that we have an ester function, carbonyl and CO. So we have this functionality. O, R, R. So let's go to mass spec and see what we can get out of it. From the mass spec, we have even number for molecular ion, so there is no odd number of nitrogen atoms. Well, we have minus 15. This means we have CH3 groups at 101. We have ion elimination of minus 31. 31 means that you have OCH3. Recall the table from the previous lecture. We have a table indicating what could be. So in the table, minus 31 means that you have minus OCH3 group, giving a peak at 85. Well, this is very clear that we have R here is CH3. If we have this part O, C, O, CH3, if we eliminate this part, we get an R. According to that, we have R plus, because we are going to get this as a radical. So we have R plus at 57. Oh, it's base peak, which means that this must be highly stable ion. 57. What it could be? What is the formula of it? It should contain carbon and hydrogen. Let's see, get the number of carbon. 57 divided by 12 will end up with 4.75. So it means that we have 4 carbon. 4 carbon means that you have 48. To get 57, that you have to have 9 hydrogen. So the formula of this ion is C4H9 plus. What is the highly stable form of this? The highly stable is tertiary butyl group. So R is tertiary butyl. Connect it together, you will end up of the compound, which is methyl 2,2-dimethyl propanoate, is your proposed structure. Is that clear? So, next problem. What is the structure of compound has the following IRMS spec? From the IR 36.6, it's above 300. This means that it is sp2ch. We have peak in the zone of carbon, triple bond nitrogen at 2230, but it seems so strong, which suggests that most likely to be C triple bond nitrogen rather than C triple bond C, because C triple bond is a more polar, and we have mentioned that changing in polarity، كل ما زاد التشينج في البولاريتي كل ما زاد الانتنسيتي بتاع البيك. Well, we are just proposing now. Okay. At 1492, 1448, this is belong to the carbon of the aromatic ring. And here is very clear from that overtone that we have aromatic part. So we don't have anything below 3000. So we don't have aliphatic part in this molecule. So the strong infrared of 2230 suggests that nitrile function. Okay. Nitrogen is probably present in the molecule. Let's see from the mass spec. Exclusive absorption above 3000 indicates an aromatic ring substituent. Okay, just to confirm what we are getting out of the IR. Now, we can see that 103 is an odd molecular ion. So we have an odd number of nitrogen. So we can accept now we have carbon triple bond N from the IR. Okay. What is the number of carbon? Because I see here 104, 8%. So this is M and this is M plus 1. And we have mentioned during the lectures that carbon 12, carbon 13, natural abundance is 100 or 99 or 98.9 to 1.1. So we can go back here and say number of carbon is the intensity of M plus 1 divided by the intensity of M times 100 divided by 1.1. 8 divided by 100 times 100 divided by 1.1 equal 7.27, which means that you have 7 carbon plus 7 carbon means you have 12, means you have an 84, and you have a molecular weight of 103. So the difference is 19 m over E mass unit. We have 7 carbon. We are proposing that we have 1 nitrogen. This leaves 5 hydrogen to make up the 103. So here is 84 plus 14 plus 5. Put them together, that's 103. Now 103, the next peak is, daughter peak is 76, which means elimination of HCN. Now we are a little bit happy with what we established. We have aromatic ring, we have nitrile functionality. If we put benzene ring with nitrile functionality, that makes C7 H5 N. This molecule could eliminate HCN as a neutral species to give benzene cation radical at 76. With no problem, we can eliminate C2H2. We can eliminate C2H2 to form a peak at 50. So our compound most likely to be benzonitrile according to this data. Okay. Problem 3. What is the structure of the compound has the following IR and mass spectra? Well, we have here in the area of OHNH, okay, we have 2 peaks. The presence of 2 peaks at 3366, 3190, this is indication of primary NH2, primary amine, okay? And again, in this area, we can see only peaks below 3000, means that we have sp3ch, it's aliphatic compound. And in the area of 1663, 1633, we have 2 peaks for amide. This is for amide. We call them amide 1, which is higher in frequency, is mainly associated with C double bond O, while the amide 2 band is from NH bending vibration and CN stretching vibration. The overlap of these two, like from 40-60%, 18 to 40% contribution in this peak. So now you recall that amide bond usually show up two peaks in the carbonyl region, amide 1 and amide 2. And we have NH2. This means that you have in your compound C double bond O NH2. This is amide. You mentioned again that you don't have any aromatic part or any vinylic part or alkene functionality. So we can say we have an R here, alkyl group. This is what we get out of the IR. Here is a mass spec showing molecular ion at 101. It's odd, and we have mentioned that the most likely it is amide, so it contains nitrogen. Odd number, okay. Nitrogen is probably present because of the odd mass molecular ion. The base peak in the mass spec is 59. Most likely it is McLafferty rearrangement product. It's C2H5NO. Ion at 44 is probably due to the alpha cleavage of the ion CH2NO. Alpha cleavage here. This part is 44. Leaving from 101 molecular ion, a fragment of 57. 57 means that you have C4H9. C4H9 means that you have a butyl group. You have a butyl group. You could have butyl group linear like this or like this. Or like this. Okay, this is 4H9, this is 4H9, this is 4H9. But the peak at 59 McLafferty, we know that to have McLafferty we have to have gamma, alpha, beta, gamma. You have to have gamma hydrogen. In here you have alpha, beta, you have gamma. You have gamma here, okay. Here you have alpha, beta, you don't have gamma hydrogen. So we can exclude this one. So you have this one or that one. Now if you go and examine the spectra again, you have 29. If you have this, how you can get the 29? While if you have linear, you can get this out. Okay? This part is 29. C2H5 plus. Okay, so the most likely that you have the pentanamide of this structure. Now we come to the fragmentation. This is McLafferty rearrangement. Elimination of this part, double bond in here, will lead to 59. Eliminating this part as a positive charged, okay, as a positive charge on this carbon, gives you 57. Elimination of NH2 will give 85 peak. Elimination from the other side will give this ion at 44. So most of the intense peak appeared in the spectra have been interpreted. Now, what is the structure of the compound had the following IR and mass spec? Looking for the infrared, there is no CH absorption peak. In the area above and below 3000, we have peak carbonyl at 1800. So the most important feature in the spectra is the absence of any carbon hydrogen absorption. The absorption at 1800 is a little bit high and weak, indicating that it is either in strain ring or surrounded by electronegative substituent. Looking for the mass spec, it's 166 molecular ion, and the next peak it's 14147, which means elimination of a piece of 19 units, indicating that you have fluorine. Elimination of 69, indicating that you have CF3 group. So you have C double bond O, you have CF3, the rest of the part are here. According to 166 molecular ion, this part is again CF3. And you end up that your compound is hexafluoroacetone. Okay? And fragmentation at fragment and 69 is CF3 plus. The fragment at 78 is C double bond O double bond CF2, and the peak at 50 is CF2 cation radical. What is the structure of the compound has the following IR and mass spec? Again, we see peaks at below 3000 at 2990, indicating that you have aliphatic part. You have again two peaks for NH2, looking for the carbonyl in this area, no carbonyl, so your compound is most likely to be aliphatic amine. Okay? Molecular ion at 59, you have mentioned amine. This means that you have an odd nitrogen atom. Okay, one nitrogen, amine, NH2, 59. If you have 59 here, and you have R, NH2, means that you have 16 units minus 16, that's 3, 4. 43 mass units is C3H7. So you have a propylamine. You have a propylamine. Okay? So you have 59, odd number. Alright. You have one NH2 group. 59 minus 16, NH2 group, remaining is 43. I don't recall that 43 is C3H7. Okay, 43 divided by 12, you get 3 carbon and 7 hydrogen. Total of 9 hydrogen. So carbon 3, but H7 plus 2 from the NH2. Okay, 9. So your compound is C3H9N. This is your compound. That's very simple compound. Okay, if you have this compound, very simple amine, you are expecting alpha cleavage to form a double bond here, and this is a base peak. At this point, we are done with part 6, session 1 on mass spectrometry, and session 2 is coming soon. If you have any question or comments, please communicate with me via ResearchGate address shown here. I hope that you have enjoyed the lecture, and see you in the next one. Bye bye.